we are aware that hydrogen presence causes the material to be brittle, but that's not a day-to-day problem. It is more for the manufacturer of hydrogen equipment who takes care of this hydrogen enrichment is taking place. Frostbite, yeah, hydrogen is much colder than zero, like at minus 252.8, colder than oxygen and nitrogen. So, and then it doesn't create much of vapor barrier on the skin. So if you touch hydrogen, it can cause serious frostbite. And another risk is, because it is so cold, atmospheric air condenses and freezes on the surface of this liquid hydrogen pipeline. So the solid oxygen layer can form on hydrogen pipeline, and the inside is hydrogen. That itself is a hydrogen situation. And again, with this pipe carrying liquid hydrogen, and in the junction it is not insulated. Most rest of it is of course vacuum jacket or some insulation. But here it is insulation. That is the point. Oxygen will freeze, and you will have a solid oxygen layer on the liquid hydrogen pipe. And then is the junction where the hydrogen is leaking. So you have all the fuel, oxygen, air, everything, all the conditions required for a plane to start. And in a hydrogen system, if plane starts, because of its low ignition energy and high release of energy capability, serious fire can happen without you seeing it, because you don't see the plane. So, what are the key features we have to see when we are seeing hydrogen? We have to see that it is placed well ventilated. Most likely, forcibly airports air ventilation, so that the concentration of hydrogen do not go over 4%. That is the more safe than to wait for 75% or more. So, to keep that low level of hydrogen in a hydrogen plant or transport station, we need a forced ventilation system. Leak detection. Leak detection is in a different level. See, when we do a pneumatic testing, we detect leak to the order of 10 to the power minus 3 milliliter per second. That's the normal pneumatic leak testing. But in hydrogen, that is not enough. Because in hydrogen, you have to go for mass spectrometer helium leak testing. All equipment are not by you. Because that's sensitive to 10 to the power minus 8 or minus 9 milliliter per second. So unless you test the system to that level, that system cannot be considered safe for hydrogen use. Even if it has pneumatically passed the leak test at 400 bar and all that, it is not safe because in helium it is still leak. Grounding is another very basic concept we have to get into our mind. Like when we are handling hydrogen or LNG or whatever, the grounding of the system to the whatever main ground system is essential. Because one of the main reasons of hydrogen catching fire is static discharge. Because it's leaky, all joints leak, we know that. Right? We don't accept it. Hydrogen leaks more because any threaded connection, any plant connection. Because it is light, it quickly goes up, so it doesn't catch fire. But the static discharge can happen at a high also. See, earthing does not always happen at the ground level. It can happen anywhere. The moment it happens, and that leaky hydrogen over 4% local concentration will start a fire. And then there will be no protection from that. You cannot really stop it because it is very fast. And then suddenly you will have an explosion and few fatalities maybe, and then you keep on investigating why it happened. But it happened because of a very silly neglect at the ground level.